Okay, so are you guys sleeping? Feel sleepy now? Most probably, right? Because after having maybe lunch and after one session. Okay, but okay, guys. So let's. This session is going to be, more or less like technical one. So you will be like, dealing with code here, right? So I hope it will make you wake up. Okay, guys. Before we start, how many of you are using AI? That not in the industry. I know that there's not much deep industry in AI in Sri Lanka yet. At least in research level or as fun. Or how many? Good. How many of you are using deep learning? Only very few. Only like 2. Okay. Because the reason why that I asked this question is that I have like 2 versions of my slide decks. It's the same slide deck, but I can skip some of the deep ones because it will be like a bit boring for you guys if you are not up to too much into AI or deep learning. But it's okay. We have some fun stuff waiting. Okay, let's begin. Okay, so this is about myself as I'm the the CTO and at Sorosine. And I'm apart from that, I'm doing visiting lecturing as well, UCSC. So as our previous speaker Dylan mentioned, that being a CTO, I'm not sitting in my desk and doing all. Actually, I don't have a classroom as well, right? Because I'm not that kind of a guy. I'm doing coding, right? I don't know whether I'm the only CTO who is doing coding, right? Okay. So these are the agenda that we are having today. So these are things that we will be going through today. First of all, an intro to deep learning, right? So you guys might have heard about these terms like deep learning, neural networks, machine learning, artificial intelligence, and all that. So you might wondering where the deep learning would fit up. So this is where it would fit up. So as if you take this as a Venn diagram, the uppermost layer we have the general AI. So anyone, can you guess what is a general AI is? Okay, I'll ask you this question. I think you guys have heard about this the Google's AlphaGo has beaten the world championship in the Go game, right? And very recently, Elon Musk's AI company, OpenAI, beat what? The world's 5 times champion Dota. 5 times Dota champion, right? So these are, I think most of you guys might have playing Dota, right? So now the Dota champion is an AI, right? So what are these what are these? Is it like narrow AI or general AI? Can anyone tell me? I have given you the most latest 2 examples in AI. Guys, these are narrow AI. So what do you mean by narrow AI? Narrow AI means that you are designing a system which specifically, do specifically something. The AlphaGo program that these guys have developed, which beats the world champion, cannot drive a car, right? That Dota champion, the AI champion that beats the 5 times world champion, a human champion, cannot drive a car, right? So what do you mean by general AI then? General AI means something or some system that you can build that can do anything, right? It doesn't have any boundary. So are we at general AI yet? No. We are not even closer to general AI. So we can start with narrow AI. And down that we have the machine learning, right? So machine learning is, then again, is more generic function. I think you might have heard about, the regression, the back propagation, and all these terms are generally goes as machine learning. So deep learning. So deep learning is very specific thing that we are going to talk about here, right? How many guys have heard about neural networks? Very good. So neural networks is about deep learning, right? There are other aspects of deep learning as well, but one of the silos in deep learning is neural networks. This is a formal definition, so I don't know to stress out about this thing. The most important part is deep structured learning, and we'll see what does that mean. Okay, neuron. Okay. So where we have these neurons in our body? In our brain, right? So this is what if you dig down deep, this is what you can find ultimately inside our brain, right? So we have mainly we have things called dendrites, and soma is more or less like where that we keep our memories, and axon terminals, right? And that and after that this one of these axon terminals will connect to another neuron's dendrite, right? Do you guys know what's happening when we get drunk? And can you stand like this? A good answer. Okay, guys. So what's happening is that when you get drunk, is that the alcohol mixed with blood comes into these connections, right? So that's why you don't remember, because in that case the soma or the nuclei here doesn't get any signals, so it cannot remember anything, right? This is the memory. Okay, so this is how the natural neuron works inside our brain. So let's go to an artificial neuron. So artificial neuron is also works in the same way, right? Works in more or less the same way. But there are some scholars that say that you cannot map, the artificial neuron into a, natural neuron. But generally this is what, right? So this is been first developed by long time ago, right? A guy called Rosenwald back in 1954. This first prototype of this artificial neuron, right? So this one is not a new thing. So as if you remember the previous one, these are our dendrites, the inputs, and you can say that transfer function. You can imagine, or there are something called weights here. This one you can think as the memory of the new artificial neuron, and we have something called activation function, which leads up to actually this is the output of this particular neuron, and it will lead up into an input into another neuron. Okay, so we stack up these things one after another, and we have the artificial neural network. Okay, so I'm not going into this stuff, right, guys? One more thing to mention: if you are keen about AI, deep learning and all that, mathematics is an essential, right? So since that this particular audience is not that conversant into deep learning and AI, so I'm going to skip these things. So this is how the mathematical equation that inside the activation function, right? So these are the activation functions that we have. I'm going to skip this one as well. The graphical representation of activation functions, right? So this is what you call the deep neural network. So you can see we have the input layer and one hidden layer and the output layer, right? So this is why we call deep, because in the simplest form of example, we have one hidden layer here, right? But when it comes to real applications, we have thousands of these hidden layers stack up together, and there are only there are like thousands of neurons per one layer as well. So that is how this works. It more or less like would look like this, right? If you come up with a real artificial neural network in the industry. Okay, so this is then again how the calculations are made. So I'm going to skip those things, right? The loss function. This is how that you measure the error in between your the expectation and the actual value, right? So I'm going to skip this one as well. Then again, some mathematical jargons that you need to in this function you need to do the multivariate calculus to calculate the error and how to propagate it to the backwards, right? So I'm not going to stress out these things. This is called the gradient descent. Forget about that. Okay, now we'll come to the fun part, right? Object detection using neural networks, right? So in object detection or image processing, we have mainly three segments: the classification with localization, and detection, right? So I think you guys have heard about the autonomous driving cars and these robots and all. So these are the main three fundamental image recognition systems that we are having, right? So classification is saying that we are having a tuk-tuk here, right? So we love tuk-tuks. As Sri Lankans, we love our tuk-tuks, right? So we cannot live. If you have heard the keynote today, even the foreigners love our tuk-tuks, right? So we cannot live without tuk-tuks, right? So it's a coincidence that I also take the same example. right? And the with localization, what do you mean by localization? You identify this particular picture, there is a tuk-tuk, and with localization means that you put a bounding box, or you identify where actually the tuk-tuk is, the coordinates, right? Detection means that you identify, you do the classification and you do the localization. Detection means that how many tuk-tuks are there. Okay, so these are the three fundamental things in image recognition. Okay. Okay, so if you are talking about classical neural networks, this is what you have to do, right? What you have to do is, you have to, in every neural network there are two phases. The first phase is called, the guys who knows about deep learning, there are two phases in neural network. Yeah, okay, CNN is one thing. The two phases are the training phase and the testing phase or the detection phase. The training phase means what? You put millions of tuk-tuk images like this to your neural network, and it identifies, okay, this one is a tuk-tuk. Okay, simple as that. It's not simple as that, but you know, I can say it is simple as that, right? And this one is called the classes, right? So that means that you can have, you know, the buses, vans, cars also inside this. And during the testing phase or the detection phase, you put one tuk-tuk in there, and it light up the whatever the neuron that resembles the tuk-tuk, right? Okay, so this is simple as that. Okay, so now in here, but we have a problem, guys. Assume that our image is 640 by 480. According to today's standard, this one is also, you know, not a high-res image. It's a very standard image, right? If we have this much of images, how many number of input layer nodes that we have to have? 921,000 something. Why? Because every pixel should get input as a, every pixel should feed to the neural network, right? Why there's 3 there? Can anyone tell me why there's 3 there? 640 by 480 is the resolution. 3? Very good. RGB. We have 3 colors, right? And if the first hidden layer contains 1 million neurons, normally the first layer goes beyond than the input layer, right? So it's normally it should be like, you know, 10 million or so. But to make it simple, I say it's 1 million. And just make an assumption. So we need this much of weights. You can see 921 billions of weights. Okay, forget about that. And if you use 32-bit floats to keep these memories, you know, 32-bit floats, right? We have 16-bit, 32-bit floats and all that. So we need this much of bits. I don't know how much it is. Huge, right? This is only to one image. Think about millions of images. So can we do this thing in classical neural network? No, right? So that's why, as a solution, we have something called the convolutional neural network, or ConNet, right? ConNet is been developed then again by studying how we identify objects, or how we see actually from our human eyes, right? So in our human eyes, what researchers done a lot of research and all, you know, whenever we see that kind of an image, there's a house there, the first things that we identify inside our human eye is the most simplest patterns, the horizontal or the vertical patterns, right? When the signal goes deep inside our brain, then we processing the deeper ones, like, you know, complex patterns. Okay, so the people who have developed this convolutional neural network taken this thing into account, and it proved successful. Okay, so this is what you do. You identify simplest things, and when you go on top of convolutional layers, convolutional neural network layers, you identify the complex ones, right? Okay, so there are a lot of, and this is how you detect it normally, right? You have the sliding window, right? And remember that, you know, this window also needs to get, you know, smaller and larger. Because why? I mean, if you compare that box with this tuk-tuk, the box is smaller, right? So it will identify only a part of that. So it needs to get larger. So now if you remember those numbers, So there's few billions and millions of numbers. Now you can think how this would go if, I mean, it would go crazy if we do it with traditional neural networks, right? Because each the bounding box should have one pass to the neural network. Okay. So these are called the CNN filters. Okay, I'll explain this thing in very simple manners, guys, right? So what is to do is, it just identify 9 pixels as is in this example, right? And identify the critical aspects of these 9 pixels. Maybe the maximum color depth or something like that, and pass it into the other layer. So you can see in the next layer, all these 9 grid, all these 9 cells are represented only by one cell, right? It goes on like that. Okay, so if you if you cannot wrap your mind about it, don't worry, right? Because this term, one of the actually he's one of my teachers, right, who taught online about neural networks and all that, is one of the the well celebrated scholars in the world. It's called Andrew Ng, right? Whenever that he taught us, he's saying if you can't wrap this up in your mind, don't forget, just move ahead. Otherwise, you can't learn neural networks, right? Okay, so I'm skipping all these things, right? This one is a thing called the polling layer. The polling layer is doing is that, as I explained you before, is identify the maximum intensity of color depth and progress into the next layer, right? Then again, just one method. Okay, so you put this thing, and you have a lot of layers like this, and we'll go to the output, right? Okay, so these are the the classical CNN architectures. The first one is the LayNet. This came in 1998, and this one is to identify just simple 10 digits, 0 to 9. That's all, right? And in 2012, there's a famous one called one network called AlexNet came up, right? And in 2014, the GoogleNet. So if you are focusing, if you are, interested in Tesla, this is what they are using, right? So you remember, try to get the year 2014. These are very recent ones, right? It's not that old. In 2015, the error rate is only 3.6. It's called the ResNet, right? And guys, all these things, what are these? What are these networks? There is a competition called ImageNet, right? Anyone can participate. Even you guys can participate. If you take down this error rate, right, up to the, lower than, if you get the lowest error rate among all others, you get 1 million USDs. That's it. Anyone can participate. So these are the winners of each year, 2014, 15, and all that, right? Okay, the YOLO algorithm. So this one is also a very famous algorithm, and even all these networks are also considered as very slow, right? But the YOLO algorithm make it very fast, because you pass only one time. You pass your image only one time to the network, right? We'll see that thing how it works in the code today, right? So then again, I'm not going into the details of this algorithm. So let's go for the demo. Guys, so if you think this is very difficult, right? But it is. I think we have a problem here. I think I have to stop. Okay, so there are libraries. The very famous one is TensorFlow. There's a thing called Keras. In this case, I'm using the library called Image AI. So you can do this image recognition using only like 10 or 12 lines of code, right? And this is Python. Okay, so in here I'm importing all the required libraries, right? If you do this code, you will also get the same result, and this code is already in the GitHub. Later on, you can get the link to the URL or to the repo, right? So in here, what I'm doing is I'm just importing libraries. only 2 lines of code, and you can see that there are few warnings are coming up. Then again, guys, doing these things in your machine and all that, it's kind of like, you really needs to get your hands dirty. Because why? The AI and all these libraries, this tooling and everything for AI is not that sophisticated yet, right? I mean, you know that whenever that you want to code C#, you download the Visual Studio, you install it and you run it, everything is there. There are no tools as such for AI yet. So you need to live with this. I mean, you cannot run everything perfectly, but there are warnings are there. That's okay as far as there is no errors. You are, I mean, okay to go ahead, right? And in here, this line is very important, right? Because in this case, what I'm doing is there's a thing called the COCO library. The COCO library means that a trained actually a trained set of weights or trained set of data which done by others. So there are millions of billions of data or images being fed into a neural network, and somebody else actually, the community has trained these things. So you do not need to train a neural network here, but all you need to do is download these all pre-trained network weights from GitHub and everywhere. It's freely available in everywhere. If you just say, I mean, there's a famous site called Kaggle, right? If you go to Kaggle, you can download many of these things, right? So I'm using that, and in this case, I'm trying to recognize an image, right? You can see, actually, I already ran the code. You can see that there are few things that is been identified. So there are few values. So these values are the percentages or the probabilities of this thing. It means that there should be a car in the image with the probability of 69%. There's a person in the image with the probability of 59%. So we'll see what is in there. Okay, typical Sri Lankan road, I think in Fort, right? So it's been identified the person, it's been identified the umbrella, but there's a thing, right? What is that? There's an issue there. Can anyone tell me what the issue is? It didn't recognize our below tuk-tuk. See, it identifies the tuk-tuk as a truck in there, and there is a one tuk-tuk is there. It just ignored that. So this is discrimination, right? Can anyone tell me why this had happened?
There were no sufficient tuk-tuk images in the training data set.
No, I mean I didn't train this.
I mean in the data set there were no sufficient tuk-tuk images.
Yes. Tuk-tuks are running in where? Is it running in USA? Is it running in Norway? Germany? I don't know whether there are BMW tuk-tuks there. Guys, there's no one in the world have ever trained a tuk-tuk into these famous databases. So that's a problem. So that's a problem that we are going to solve now. So we are going to do a justification to tuk-tuks now. Right? So what we can do, the first thing what we should do is, if we encounter this kind of problem, the problem is that, as you correctly said, we don't have data. We don't have enough data, right? So the first thing what you should do is, you should go to, there are famous image sites there. This one is hosted by Google, right? There are pre-trained millions of images are there, right? So what you can do is, you can go there and search for tuk-tuk. It's not there. 3-wheel? No. This is more discrimination now. What is this? they don't train it, and they don't have even a single tuk-tuk image in their database. This is the largest image recognition database in the world. What is this? So then we have to leave it by ourselves, right? Okay, so let's localize the problem and solve it. Then what you have to do? What you have to do is, you have to go to the internet or go to the road. If you go to the road and stand there, 10 minutes, you can take, hundreds of tuk-tuk images, right? or just Google it and download all these images, and you need to retrain the network, right? So I'll explain how to do it. So I have downloaded only like very few number of tuk-tuks, right? I think only around like 100 images. Right, so this is my tuk-tuk database. So this train database images, right? So I have few tuk-tuk images there. These I have downloaded from the internet, right? And then what you have to do? Then you have to do something called identify tuk-tuks in the images. I mean, feeding these images as it is to the network won't do, because it doesn't know what is a tuk-tuk is. So then what you have to do? You have to do something like this. Right, there is a tool called image labeler, right? You download that, and what you have to do is you draw this bounding box using your mouse, and you know, there are a lot of bounding boxes. If there are more tuk-tuks, then you can do more bounding boxes there, and just save it. I mean, this one is creating something called a VOC elements, as in XML formats. So what it do is it takes the image name and say how many tuk-tuks are there, and if there is a tuk-tuk, the coordinates, or these 4 coordinates.
I didn't catch that.
Right? These 4 coordinates, okay? In XML format, or else you can, there is another format called YOLO as well, but in this case I am using the VOC format. And then what you have to do? You have to train the network, right? You have to train the network. So I'll show you the code for that. Then again, it's very simple. Right? So this is the image. You import all the required files, right? And you mention your data directory there, tuk-tuk2, and this is my label for tuk-tuk, right? You have to mention the label. And this one is very important, guys, the pre-trained YOLO. This means that you cannot train, an empty network. So this one is called transfer learning. Transfer learning means that you took an, a pre-trained network and retrain that with your image set. So that is called the transfer learning, right? So you download that and you push your recognition into this one, right? And train the model. Okay, simple as that. How many lines? I think 7 or 8 lines, right? Simple as it is, right? Because we are using the image library. So then what would happen? Can we do this thing? The problem is, can we do this thing in our normal machine? So this is what will happen if you are going to do this thing in your normal machine. You can see the CPU, guys, sorry about the resolution, it's very low here. The CPU rises up to 93% just for within few seconds. Right? This is in my laptop. This is like, it has 32 GB and the blah 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 it goes and everything. Right? So can we do this? I mean, this only 100 images that we are trying to train here. We cannot do this thing. My machine will blow up after a few minutes. So then what's the solution? The second solution is that the Google is offering some services to you guys, right? Called the collaborative lab, right? So as this for the researchers and all. So what you have to do is you have to go there and you have to upload all your images and all the whatnot required files, folders and everything, and train it in there. And remember, guys, this one you can use the Google servers GPU. What is a GPU? The graphical processing unit. So normally you are training neural networks with GPUs, right? So you use their GPUs and train it, right? Even this thing, even with these standards, right? I did only like 10 cycles of training for our example here, right? Even this one took around 30 to 40 minutes. Remember, this is a Google server, right? 30 to 40 minutes, okay? So these are the difficulties of neural networks or deep learning at the moment, okay? So now we have it, and then what it do is its output then again an H5 file, right, as your memory from this training, and then you have to download it and then you can do your recognition. So this is the sample recognition that I had. You can see. Finally, we did the justification for tuk-tuks. Okay, so it correctly identified. But then again, guys, I'll show you some of my local results as well. I'll show you the same object, tuk-tuk detection, right? So yeah, so it identified this guy. We'll use the same image again and try to do it in live here. It's called, I think, image JPEG. Okay, they are called image JPEG. Okay, I'll run it from the beginning. Okay, and this format is called the IPython B, right? So it's a very easy to use coding format. We'll see. See, okay, it identified. We'll see. Okay, so maybe it's okay, right? Justification with 100 images, this is okay, guys, right? Actually, guys, if you want to do this thing in practical scenarios, right, then you have to have at least 10,000 images of tuk-tuks and do the the boxing for 10,000 images. I think because I tried a lot to find whether someone else did this thing, so I couldn't find anything. So I think this is the first time the justification for tuk-tuk has been done in the whole world. Right? So you can see still, it's identified this lorry as a tuk-tuk because we had lack of data, because of the lack of data, and yeah, apart from that, others are quite okay. Okay, so you can do this thing by go home today and do this thing. The code will be there, right? You can do it by yourself. Okay, so okay, about YOLO, I'll show you one last thing, guys. I think we have 4 minutes. Because I told you that identifying images, because the YOLO algorithm makes the identify images very fast. We'll see. Then again, I'm using the code sandbox, and it's in the cloud, and I have used a simple React program to build some kind of a web form to identify this. Okay, hope it would work. Do we have the connection? Yes, you can see it identifies me, right? So this is real time. Okay, this happens because of what? Because of the YOLO algorithm, right? It has actually the paper says it has only 25 milliseconds of latency. So we'll try to identify you guys as well. We'll see whether this will work. Is it there? Okay, yeah, few guys have been identified, right? Okay, so you can do some cool stuff like this as this with image recognition. Okay, so guys, but this subject is bit like bit deep as deep learning implies, right? But it's very fun, and mind you guys, there are few cool products that that we did, right? Not in the company, 3 or 4 of our guys, we are doing this thing in in our weekends and all that. But I cannot show you everything because patents are pending, right? Sorry because of that. So there are a few cool things that I did, right? Actually we did. There are a few other guys, right? So this is I make this as an an inspiration for you guys to come into this field. And one more few things that I want to show you guys. These. Okay, let me. Okay, so these are the. Yeah, these are the the famous papers for this thing. This guy, he's Jeffrey Hinton. He's the guy who's identified as the father of deep learning, because he has dedicated a lot of his time for this thing for like I think 4 or 5 decades, right? Because a lot of people have ignored these neural networks and all that in 60s and 70s, but he still hang on there and he did a lot of work. And one more thing, guys, if you go through these names, these are the world famous papers. Can you identify a pattern there? The research, I mean the researcher's name or the publisher's names. Most of them are Asians, right? Chinese guys and all that, Santos, I think he might be an Indian, right? But these guys you live in Canada and UK, US, right? But this is the thing, guys, right? Because if you think about AI, right, and these are cutting edge technology, and this technology is driven by Asians, right? If you think about, can anyone tell me the number 1 AI company in the world? Yeah, Google is doing, all their publishing, the blah, 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 show off thing and everything. But the major work is done at Baidu. Baidu is a Chinese company, right? Most of the Chinese train stations are, they have the facial recognition systems, and you don't have to swipe your card and go into the train, right? You are being identified by your face, just walk in. Most of the offices in China, right? So they are very advanced. So what we can do is, guys, we also can do it, right? We also can do it, right? But it's a brand new field, and the demand, as they are speculating, by 2025 is more than 3 trillion USDs for the AI field, right? So if you want, you can go there and do some fun stuff and earn some money and become rich, right? You can do it. Okay, guys, and that there are a lot of things, since that the election is going on, a lot of people are talking about AI as well. But this one is different than that, right? This one is totally different than that. So guys, okay, you just scan this place and it will go, it will redirect you into my website, and you can have the links there to download the slide deck and the link to the Git repo, right? So any questions, guys? No questions? Okay, so these are the things, guys, in Sri Lanka, this is what happens, right? If you do this thing in like New York or San Francisco, there will be like, as far as I tell 10 questions, 10 guys sitting here, or 20 guys, right? I experienced that, right? Okay, guys, it's okay. So thanks. I hope, I did some inspiration to you to step into a new field, right? So if you have anything, just reach me. I'm there in LinkedIn, Twitter, Facebook I'm not using, right? Because it takes time. I don't have time to waste. Okay? So Twitter and LinkedIn and all that, you can reach me. Drop me an email if you need any consultation or any help. I'm there to help you guys. Okay? Thanks, guys.